A very good morning to all of you. Today we have started the revision class on unit number 1. Today we will see that uh, further of the unit number 1. If possible, we will see the unit number 2 also. Okay. So yes, we started yesterday the welded connection. I have seen the two types of weld, that is butt weld and fillet weld, and in that how you can join. This is the fillet weld, and these are the butt welds and different types of butt welds. Also, we have seen, and the IS specification for welded connection, that is section 10.5 of IS code. IS 800 2007. And you know that at the end you need to provide an end return. This is the end return, and it is nothing but it should not be less than 2 times the size of weld. 2SS is nothing but size of weld. And also we have seen the table number 21 for the minimum thickness of weld. S minimum as per the thickness of thicker part of plate, and the maximum uh, thickness of your uh, plate from the figure 17 of your IS code. So in IS 800 2007, if you go for section number uh, 10, section 10, there the figure number say 17. You can see here the figure 17. If there is sharp edge, then the maximum thickness of weld will be thickness of plate minus 1.5. Or if there is round edge, if your road is section you are using, then in that case, the thickness of maximum size of the weld will be T minus T by 4. T minus T by 4. Okay, or you can say that the maximum at the round is the 3 by 4th of thickness of your plate at the round edge, and the throat thickness based on the this table, based on this table number 7, just for table number 22, based on the your angle with the edges. If it's 60 to 90 degree, then the value of K is 0.7. Okay, if it is 91 to 100, then the value of K is 0.65. So here this throat thickness, that is effective throat thickness, is nothing but if you write down, that is nothing but K times S. Effective throat thickness is nothing but K times S, and the value of K is going to be taken from table number 22 as per the angle uh, of the two plates, how we can join. Okay, so if the length, if the angle is increasing, then their constant the value K is decreasing. You can see here, if there is 101 to 106 degree, then the value of K is 0.6, 107 to 113, the value of K is 0.55, and if it is up to 120, then the value is uh, the value is zero point 0.5. Okay. So these are the from here you can take you can find out the effective thread throat thickness from clause number 10.5.1 3. Okay, so here again the effective length of fillet weld is nothing but actual length plus uh, uh, 2 times of TT, 2 times of TT. L plus 2 times of TT, this means the effective length. Okay, so 2 times L plus 2 times of 4 thickness is nothing but your effective length of your fillet weld. Okay. So design of fillet weld, there are clauses and that is given that FWD, which W is nothing but FUN upon gamma MW. If you write down this, so FWD will be the, nothing but FU root 3 into gamma MW. Gamma MW is a partial safety factor for material and that is taken from the table number 5 of IS Electric Unit 2007 and that is given page number 30. Okay, so this is the design strength of fillet weld you can see, and again the stress due to individual force it is given in IS code, that is Q is equal to P upon Dt into LW, and you can see this formula in your IS code also. You can see here FWD, this is given in clause number 10.5.7.1, and again you can see the Q, the shear force alone, the stress in the weld is resisted, that is Q is equal to P by TT into LW. When we equate these two, the formula, these two formula when we equating Q is equal to FWT. So can equating this, so P upon PTW NW into FU upon FU in gamma NW. So length of weld required, you can find out if you know the load, if you know the load, you know the load, the load is known, and road thickness you can find out from the size of weld, से आपको मालूम हो जाएगा, and if you know the ultimate stress of your steel, so length of weld you can find out LW is equal to P under root of 3 gamma MW divided by PT into LU. Okay, so likewise you can find out the length of weld, length of weld. Okay, so this is the formula you can use to find out the length of weld. Or if you know the length of weld, if you know or the length of weld, if you know LW, then P you can easily find out. P is equal to FU into PT FUPT into LW divided by root 3 into gamma MW. So you can easily find out the value load. Okay, so that is you can easily note down. So to find out the load carrying capacity of bed, strength of welded connection, then PU you can write on this. Okay, this formula you can use and you can easily find out that strength of your load carrying capacity of your bed. Okay. Now, if you have to find out the per mm uh, load, strength of weld, per mm strength of weld, PU, then this FU into TT, root 3 into gamma MW. So this length of weld you should not required. So strength of weld, per mm strength of weld you can easily find out by using this formula. And when you know the force, if you know the force and you know the load, you can find out the length of weld, and that is nothing but all the terms will be on the other side, and you can easily find out because you know the load here. Okay, all force here. Okay. Now here are the few examples you solved already earlier. So I am not going to solve this sheet already shared with you yesterday. So based on that, you can change the values, the size of plates and thickness of plate, and you can solve the example your own and try to solve at your own uh, from the assignment notebook, no issue. And you have to find out length of weld if there is uh, eccentric loading. If there is angle section, then the CG will be a knot at the center, then the load at force is not equal at both ends. So the length of weld will be nothing but A plus B. You have to find out based on the axis if there is no eccentricity. Because if angle section is there, then outstanding leg are there, and there should be the CG is accumulated or near to the outstanding leg. That's why your length of weld required at that leg is large because the load transfer near that portion is large. Okay, so that's why how to find out the in case of this angle section, how to find out the length of the detail. So these are many such examples are there, and you can solve this easily. So we are not going for that. You can solve your own and uh, try to solve the example given in your instant examination. At the last of this your welded connection, I have written the design steps for the welded connection. So, so you have to decide the minimum size of weld, table number 21, maximum size of weld, figure 17, page number 81. This page number 81, not page number 18. We written. So page number 81. You can also the calculate the throat thickness. It is if the angle is up to if the angle is up to 90 degree, then you have to use this formula. The K value will be 0.7 from table number 22. Okay, then calculate the strength of weld, and that is you have to equate the FWD is equal to Q, and you have to equate the FWD is equal to Q. The both formula from the IS code you can take, and based on that you can find out easily the length of total length of weld. And as per the requirement, if there is angle section, then length of weld, total length of weld is nothing but A plus B, and based on the CG of the section or axis of CG of the angle section, based on that you can find out the value of A and B by equal axis step. Okay. Now, in step unit number 1, the base design of tension member is also given. So the member is having the axial pull. The member is having the axial pull. That member is called as tension. So there is tension in the member. There is tension in the member due to the pull. So if the axial pull is there on the member, then that is called as tension member. So many times the tension member design is also ours in the examination. And one example is compulsory on the welded connection or welded connection or tension. So either on any one type of example we ask, sometimes in option the tension member design is compulsory. So tension member you know that if there is axial pull on the member, and that member is called as tension member. That member is called as tension member. Okay. So here different types of members you can use for the different type of loading, and that may be the solid rectangular bar, circular bar, square bar, angle section, unequal angle section for we are using for light load. If medium loading is there, we are using for the channel section, I section, T section, two angles back to back of the gusset plate to angle one side of the gusset plate. And if there is heavy loading, then we are going for the built-up section. Two channel section you can use pasting illustrator, or two channel back to back, or four angle section you can combine together for the your uh, tension member. Okay, as per the requirement, you can use it, or you can go for that based on the loading conditions and tension member. In truss, most of time angle section are used, or there are three types of failure you can observe in the tension member, that is cross section yielding, net section rupture, and third one is block shear failure. Okay, so in cross section yielding, generally you need a gross area. In net structure require you need a net area. Net area you have to calculate based on the section given and based on the bolt with bolting conditions. And block shear failure, the failure in shear as well as in tension both, then that is block shear failure is both the condition, that is it is called it is TDB1 and TDB2, or design strength and block shear. And cross section yielding, that is TDG and TDL is the net section rupture. All these values are given in the section 6 of your IS code. So when you are going to design the tension member, so you have to follow the section 6 instruction, the design of tension member. The T should be less than TD. TD is the design strength of member, and design strength of member is minimum of the TDG and TDL and block shear failure TDB. Okay, and that is explained in 6.2, 6.3, and 6.4 respectively. Okay, so design strength yielding of cross section, that is TDG is equal to AGFY upon gamma n O, and you know that this formula is already been used, that is from the clause 6.2, that is TDG is equal to AGFY upon gamma n O. Fy is the yield strength of material because cross section yielding is there. Therefore, there is yielding. If there is yielding, then you have to use gamma MO, the partial safety factor for yielding, and that is taken from table number 5 of your this same IS code on page number 30. This is many times I have debated. Then the design strength due to rupture of critical section in case of plate, TDL is equal to 0.9 ANFU upon gamma M1. Here you have to find out the net effective area of the member. If bolted connection is there, then you have to deduct the hole to find out the net area of the section. So if you find out the net area of this section, because the thickness of your plate is, if I will consider, is B, okay, there is number of bolts, it may be 2, 3 in one line, then net area of section is B minus ND0 into T, okay. So if you write down BT is the whole area, and then ND0 into T, D0 is the diameter of hole, D0 is the diameter of hole, and you can deduct the hole diameter, and if n is the number of holes, how many number of holes, that you can deduct number of holes, and you will get the net area of the section. Okay, so if there is staggered pitch, then the formula is also given, and you can use that formula, and that is given in IS code 800 2007 on page number 33. The An is equal to B minus ND H or ND0 plus summation of I2. Okay, T square upon 4GI into T. So you can modify this formula, and you can write down this An is equal to B minus ND0 summation of T square 4GI I is equal to 1 to n number of both, or okay. So An is equal to B minus ND0 plus P1 square 4G1. P1 is pitch 1, G1 is gauge distance 1, P2 is P2 gauge is the truth, P2 square by 4 P2 plus 7. That's how many number of stagger features there. We'll go for that. To we'll get the net area in case of stagger pitch. So this is net area in case of net area in case of staggered staggered pitch. Net area in case of staggered pitch you can find out. Okay. Now here are the examples how to find out the net area of the section. So these two plates are connected with number of board. You will find out the critical section where the failure can occur. So where the area uh, is maximum, so that is safe. If there is area is minimum, okay, then you can say that there the failure will occur. So in this case, we have suggested 1 to 2 is one path, 1 to 2 to 5 another path, 2, 3, 4, 5, 6 one path, again 6, 7 and 5 another path, and these three paths, failure path may occur, and 6 to 7. So they are a different path, and based on that we'll find out the net area and where the minimum net area will get. That area is nothing but the critical area. So if you find out these areas, you will get that your critical area, and you can suggest that the failure may occur from that path. Okay. Here also another example of the angle sector. If four legs are connected, okay, that also you can find out. And if one leg is connected, that also you can find. There are different examples are given of bolted and welded connection. You can solve this to find out the net area in case of rupture. Okay, and also there are examples to find out the yield strength or shearing strength. Yield strength, design strength due to welding, and design strength due to net section rupture, or a design strength due to block shear failure. So many such examples we have already solved. So I will repeat the steps how you can design for the uh, and tension member. So this we will select one example so that you can easily find out how to find out, and then so already I have uh, explained you how to design a tension member, but this example once again we will see step one by one so that you can understand. So here the longer leg of single angle section, I say 125 by 25 8 is connected to 10 thick cassette plate uh, by 4 bolt of 18 diameter as shown in figure. So this figure is given, and 4 bolts are connected with the cassette plate, and the size of the angle is 125 by 25 by 8 Thickness of the cassette plate is 10 is given. So you can write down the way to find out the design tensile strength of member. So design tensile strength of member is nothing but the minimum of TDG, TDN or TDB1, TDB. So TDB is there is two types of TDB: shear yielding, tension rupture, tension yielding, shear rupture. That's why TDB1 and TDB2 are there. So the design strength of tension member is minimum of these four, that is TDG, design strength due to yielding, design strength due to net section rupture, TDN, and block shear failure, that is TDB1 and TDB2. based on the shear yielding tension rupture, and this one is tension yielding shear rupture. So the minimum of this four value is nothing but the strength of your tension member. So first, because you know the section, you know the gross area. So just put the gross area here, and you know the Fy is 250 and gamma mo from table number 5 of IS code you can select, and that is if welding is there, then gamma mo you can take, and that is nothing but 1.1. But if rupture is there, if rupture is there, net section rupture is there, okay, in that case, you are going for the ultimate load, ultimate strength of the member, then in that case, the partial safety factor for material will be taken as 1.25 in case of rupture. Okay. So when there is angle section, the IS code is given for the single angle section. How to find out the TDL? Okay, so the formula is 0.9 ANC FU upon gamma M1 plus beta H0 Fy upon gamma MO. So this you have to find out, and that is explained here. So TDG you have find out, that is coming around TDG is 349. Okay, 350, almost 350 kilonewton. This is your T. Okay. Now you have to find the next section rupture using this formula. TDL 0.9 ANC. ANC is the net area of connected leg. Ag0 is the area of outstanding leg. Because only one leg, longer leg is connected with your gusset plate. Okay. So this is the longer leg which is connected with the gusset plate, and the size of angle it is given, I say 125 by 25 by 8 mm. Okay. So here you can write down if one bolt line is there, I have drawn here two bolt line. If one bolt line is considered, then you can write down 125. The connected leg is longer leg, that's why 125, that is B minus ND0, ND0 minus T by 2 into T is nothing but the area of connected leg. You can find out. So you can see the B is 125 for longer leg is connected, because this value is longer leg is 125 mm. Okay, and shorter leg is 75 mm. Okay, so put the longer leg length into 1 into 20 minus T by 2, 8 by 2 into T is thickness of angle is 8. So you can write on that. So you can find out ANC is nothing but 808 mm square. Similarly, the area of outstanding leg you have to find out, because outstanding length is having shear lag effect. So outstanding length you can find out, that is 75, the shorter leg is 75 minus T by 2 into T, you get the area of outstanding leg. If you add this, then the total area, net area you can find out, that is 808, that is area of connected leg plus area of outstanding leg 568. If you add this, you would get the value 130, 1060. So this you find out the area ANC and AG0, you know. Now you have to find out the value of theta, because in this formula I have to find out TDN. TDN is equal to 0.9 ANC FU over gamma M1. Now this you know, this value you know, this you know. M1 is 1.25 for rupture, and here yielding of outstanding leg is there, AG0 and Fy. Because here yielding, that's why gamma MO, but this value beta you want to find out. So beta you can find out, the beta you can find out from this formula, that is this formula, no need of remembering. All this formula is given in your I 800 2007. So if you see the IS 800 2007, you have the beta is equal to 1.4 minus 0.076 W by T Fy upon Fu T DS upon LC. Okay, what are these values? So these values, W is the outstanding limit. Outstanding W is the outstanding limit. W is 75. Outstanding limit. Okay. Now DS is the shear lag width. Shear lag width means this width, that is W outstanding width plus the CG of this. So DS will be W plus WI. WI is nothing but minus T by 2 here, T by 2 here. It means that minus T. Okay. So you can find out the BS, and LC is the length of connection, that is center to center distance between the end bolts. Okay. So length of connection, you can find out the center to center distance between the end bolts. Okay. So how many number of bolts are there? Based on that, you can easily find out the LC. Okay. So this 1.4. Okay. W by T. W, if y 250, if 110, PS you can find out easily. Yes is W by W1. So this is you have taken the CXS for 1.5 from the steel table, or otherwise you can assume uh, the value of this CG, where you are boiling the connection, to center of connection if you know. So based on that you can find out the value of BS. Okay, so it depends on you. Okay, it is depend on you that how you can consider. Okay, based on that consideration, uh, based on that consideration, uh, uh, you have to put this WI value you have to consider. Okay, and then this shear lag rate yes you can find out easily. If you consider 3 into pitch, okay, pitch is 2 point, minimum pitch is 2.5 times of D. D is 18 mm. So 2.5 to 1845, you can also select the pitch 50 mm, no issue. So you put all the value, the W 75 by thickness is 8, so 50 upon FU, FY upon FU, and 1116 WS, and MC is 150, so beta is 1.06. Now put this value and you can get the TDN value. TDN value you get 375.35 kilometers. So now you got the two values, that is TDG and TDB. So TDG you have already got, TDG you have got 350 kilonewton. Okay. Now TDN you got 375.4 kilonewton. Okay. Now you will find out the block shear failure. Block shear failure in tension member. So because four bolts are given, so you have to find out the block shear failure. So block shear failure generally it is occurred in some place is designed for drawing. So here I will draw. So if this is angle section, this my angle is connected with four number of bolts. Okay, one, two, three. Okay. So angle is connected with this is plate, four bolts. Okay. So block shear failure, if I will draw the diagram, it will be this from here. This plate will be break. So this shear and tension of plate will get with the gusset plate, because the thickness of gusset plate is 10 mm and this thickness of angle section is 8 mm only. So definitely the failure will be in the angle section. If you draw the pattern for the block shear failure, it will be like this. This will be out. This is the outer staying leg. Okay, so this is the block shear failure. So how many bolts are there? One, two, and three, and four. Four bolts already given in our design, and we know that pitch distance is 50, so it is 50 mm, 50 mm, 50 mm, and end distance you can find out 1.7 times of D0. So 1.7 times into D0 is 20 mm. So you can find out uh, that value. Okay, so this is how the block shear failure is there. So here you can see that there is two types of failure. Here, if I will say that this plane is for tension failure, and another plane, if I will show with the some another color, this plane, there is a shearing failure, shear failure. Okay, so that's why in block shear failure, both failures are there, and there are two combinations. Two combination. The first one, TDB1 will be shear yielding tension rupture, and second combination will be tension yielding shear rupture. So in this terminology, if you know, so you can able to make your own formula. Shear yielding means the yielding means gross area ABG here FY, and if there is yielding, then gamma MO. If there is shear, 1 upon root 3, this conversion. Okay, so this formula you can make your own. Here, if net section rupture, if rupture is a tension rupture, tension is the net area in tension. In tension, we are considering only 90% of strength on my FU. If there is rupture, and if there is rupture, then partial safety factor for material is gamma M L. Okay, so you can make the formula. Okay, so you can find out TDB1. So TDB1 is common means 373 km. Now you can find out TDB2. How to find out TDB2? So TDB2 you can find out the tension yielding shear rupture. So here tension yielding means gross area in tension. If yielding is there, then yield stress of material, that is Fy, and partial safety factor of material is gamma M. Plus shear rupture means the net area in shear. If net area is there, then ultimate load stress you have to consider Fu, and if there is Fu, if rupture is there or ultimate load, space of load is there, then the gamma M1, and because there is shear, so root 1 upon root 3 will be there, and due to tension, so 90% we are considering, that's why 0.9. Okay, so this values you can put, will get the TDB2 is 315.434. Now from the total, you can see that we will got the TDG 350 almost, TDN 375 almost, TDB1 373, and TDB2 you got 315. About 315. Okay, here you can see that the TDB2 value is the lesser in all the four values. So design strength of your tension member is the minimum of all these four values, and here the TD will be nothing but TDB2, that is 315.43 kilonewton. So if there is design of tension member, so you have to follow these steps, and from that, if the angle section is there, you can go for that. So this is designed for the tension. Okay. So here you can say your tension member design is over. And what is the lug angle? I explained earlier. Lug angle is nothing but angle. If the length of connection is short, so you are providing the additional angle, and this additional angle is called a lug angle. Okay, so if your length of connection, if you are provide a connection, but your cassette plate is heavy, very short, and you need around uh, six number of bolts, but you have only place of providing only three bolts. So where you will provide the three another three bolts. So for that you will attach another angle section, and that additional angle section is nothing but it is called as uh, the lug angle. It is called as lug angle. So where the lag angle is needed, if the length of connection is short and you have to provide additional angle to complete the connection detailing or to complete the connection, then that is called as lag angle. Splices, if there is two tension member are there, one having the thickness T1, another is thickness T2. Okay, so here the thickness, if I will say is 20 mm, and here thickness is 12 mm. So here should be the connection will be not good. So you have to provide the additional packing plate of 8 mm to uh, avoid the losing of the connection, or to provide an additional plate for the good connection between the two members. Okay, so that's why the splices are needed. Okay, or if the length of member is short and you have to provide, or if there are different size of member and you have to connect with them, so you need additional packing plate, and that is nothing but called as splices. So splices, it may be between the two same size of member if the length of member is short, or if there is different sizes or thickness of member, then you have to provide additional packing plate to complete the splices. So this is what all about your tension member design. Okay. So tension member design problems are two types of problem. One is analysis type problem, another is design type problem. In analysis type problem, you have to find out, the section, here you know the section, here you know the section is known in analysis type of problem, and you have to find out the load carrying capacity W or P for the section. Here you can calculate the load, can load is known, okay, and you have to find out the sectional properties, or you have to decide the section, and that type of problem is nothing but it is called as result and proof. So this is all about the revision of unit number one. Uh, in case you have any doubt, you can ask with me. Otherwise, stop here, and then another uh, revision of unit number two. You will be interested. Okay. So if you have any doubt, you can ask with me. Otherwise, we stop here. So here you guys, Munad.
No, sir.
तो सब समझ में आ जाता है, तो वेरी जीनियस. So shall we stop here, and then I will share the unit number two notes also. So we can go through that unit number two material, and best of luck for your recent examination. We have a short of time. Okay, if you have a good time, I will inform to you for unit number two revision. I don't think that unit number two needs to be a revision. In the design of a compression member, very simple steps for design. In case of built-up section, there are large number of steps for the lacing system, battery system, that already I have shared with you. Okay, and already some pattern I explained you, and I will share with you a video also. The initial examination will be conducted. So best of luck for your initial examination. And still I will still, if you have any doubt, you can ask with me. If you are any doubt in any way, you can ask with me. Or so after now your recent examination, you will focus on the completion of new project. Two new project, one already completed online classes, and we will start with the project two that